Okay. Last topic, I guess, hopefully in this chapter. Okay. Isoelectronic series. Kind of we already discussed it, but in terms of electron size and its atomic radius, in comparison to isoelectronic series, we already know that different cations, when I say cations, an element with a positive charge ionic form, and different anions, when I say anion, I mean to say an atom with a negatively charged species. So it is called anion. The reason metals lose electrons, forms positive charge to turn into cations is because they will have the similar electronic configuration of the noble gas that is closest to it. And the reasons nonmetals would accept the electron and through the electron affinity process and become more stable is because by accepting that extra electron, even though it increases the radius of that particular element, it's because it can have the similar electronic configuration with the noble gases. Okay, so what we're trying to do is, if there is a noble gas that is going to be copied by a metal by charging cation, that is going to be copied by a non-metal by forming anions, what it means to the size of those, all of these species that has the same number of electrons now, right? They can't be exactly same because there are going to be different factors involved in the neutral element and positively charged cation and negatively charged anion. So because there is going to be different attraction between nucleus and outside electrons. So we are going to discuss it here. If you have a neutral noble gas such as neon with its atomic radius that is already defined, a fixed number, if you have two different non-metals that is trying to copy the electronic configuration of the noble gas from the same row, right? Same row, left to right. The element that is smaller and accept only one electron is going to be not much, little bit larger than the noble gas, while as the element that is going to require to accept more electrons is going to be much larger than the noble gas. Okay. Here you can see it with example. Oxygen 2 looks like much larger than the fluorine -1, even though they both have same number of electrons now compared to neon, right? Still, oxygen 2 is much larger because just like we discussed in ionic radius of the ions, by accepting an extra electron, you're creating more repulsions. So for oxygen 2 to have the noble gas electronic configuration, it has to accept 2 electrons. But if it accepted 2 new electrons that does not belong to oxygen in the first place, you are creating a lot more electron-electron repulsion. So it has to get swelled and become bigger than what it should be. That's why it is larger in size than neutral noble gases. In this chapter, I really like this topic for predicting predicting the ionic radius of ions in terms of once it forms the ionic charges in comparison with noble gases. I'm pretty much interested in the topic, and if you see that it is included in the practice exam for the first midterm exam I give you. So in general, I try to throw a couple of examples of either noble gases, just like in the question, with the combination of cations and anions that is going to have a similar electronic configurations. And I will ask you to arrange them in an order to have them from smaller to larger and larger to smaller ionic radius, especially not atomic radius. Atomic radius, you can get it from the periodic table. Trends you can easily predict, but ionic radius you cannot easily predict, because for metals, if it forms cation, ionic radius is going to get significantly smaller. For non-metals, if it accepts electron and forms into anion, the ionic radius is going to get significantly larger. So it's not easy to predict, and you need to know individual trends of the metals and non-metals to answer this question. Okay, let's jump into answer this question and wrap up this chapter. So whenever I throw this kind of question, first of all, you need to figure out, are you referencing to, in the collection of elements, are you referencing them to having same number of electrons or different number of electrons? First thing that pops out of this question is neon and argon. They both are noble gases, and they both have different number of electrons, right? Obviously, and we know that neon is smaller than argon. Let's see what is the order that we are asking, increasing the radius size. So neon is going to be smaller than argon, we know that. So, oh, even there is a krypton too. So krypton is also noble gas, much more larger. So we are asked to arrange them from smaller to larger. We already know that because there are three noble gases and they have fixed atomic radius, and atomic radius in a period, in a group from top to bottom increases. So I already know that neon, argon, krypton are going to be in this order. Now I have to find what is the ionic radius of these ions. There is K plus, P negative 3, and sulfur negative 2, and chlorine negative 1. And we need to refer to periodic table again for this. There you go. So what are those? One is a K plus, right? One is K plus, and another one is a P negative 3, sulfur negative 2, chlorine negative 1. Looks like they were all around argon, right? So one thing we can pretty sure say that because we have a neon, argon, and a krypton, right? And neon, argon, and krypton, now we can pretty sure say that what are the charges or cations, anions we have are going to fit between neon and argon. So we just have to arrange them between neon and argon. We need to know which one is going to be smaller, which one is going to be larger. So K plus is forming positive charge, and we know that whenever these metals from group 1A, 2A, 3A, main group elements, whenever they lose an extra electron or 2 electrons by forming charges, the reason they do that is that they will copy the electronic configuration of previous element, which is argon, so it's going to be smaller, okay? So K plus is going to be smaller of P negative 3 and sulfur negative 1 and chlorine negative 1, sulfur negative 2 and chlorine negative 1. So between phosphorus, sulfur, and chlorine, we know that chlorine will only need to accept 1 more electron to act like argon, and sulfur need to accept 2 electrons, phosphorus need to accept 3 electrons. But we also know that if you accept more electrons to copy noble gas electronic configuration, you're going to have to deal with a lot more electron-electron repulsions in your outermost shell, which means out of all 3, I would say phosphorus negative 3 is going to be a lot more bigger than sulfur negative 2 and chlorine negative 1, which all of them is going to become much more larger than argon. K plus will be smaller than argon because it is losing 1 shell but having 1 more extra electron, and it's going to be smaller than argon but larger than neon because difference in sizes of shells. So I would say neon and K plus, and I would say argon after K plus, even though argon is smaller than potassium, but K plus will have a smaller ionic radius than argon. Now after argon, I would say chlorine negative will have a smaller size between S2 and P3. After Cl minus 1, I would say sulfur negative 2 and phosphorus negative 3. Lastly, krypton because it has entirely different shell. Let's find what we have. Right? You have, oh, I forgot to put, oh, the question is asking, okay, I didn't completely read the question. It's been too long since we started lecture. The question is asking first, identify the isoelectronic series. I did not see that. So you don't have to worry about apparently neon and krypton because they were not isoelectronic with rest of the elements. So, well, I answered for different right question. So for this question to answer it right, let's exclude neon and krypton, which actually makes it more easier to answer this question because I I wanted to answer a much harder question, I guess, for some reason. So only elements that have isoelectronic configuration in this given set is K plus, argon, P negative 3, chlorine negative 1, and sulfur negative 2 as well. It is not included in this list here. Sulfur negative 2. So in order of increasing radius, because K plus has greater Z effective, because more protons in it, by losing an electron, if it has 18 electrons, it will have smaller ionic radius than neutral argon, and the chlorine with 1 extra electron has smaller ionic radius than sulfur with 2 extra electrons, and phosphorus with 3 extra electrons. All right. Don't know how long it took to complete this chapter. Let's see. Probably 3 hours ago, I started this lecture. I might have taken breaks of 10-15 minutes, a little bit longer for phone calls. At least 2.5 hours of lecture, I guess. Not too bad. If we have to do it in actual lecture, we will have to do it in 1.5 classes, 2 hours of lecture on one day and another 1 hour. It would take about similar 3 hours. Or maybe 4 hours if we discuss a lot more, but still again we can discuss more in the class if you have more questions from this during my office hours. But these are the key points that we discussed from this chapter. We discussed the development of periodic table and the modern periodic table, how we come to the modern periodic table, the difference between individual Mendeleev periodic table to modern periodic table is that initial periodic table by Mendeleev uses the atomic masses rather than the modern periodic table, which uses the atomic number to classify elements and classification of elements. Like, there are periods left to right, groups top to bottom, and we discussed about valence electronic configuration, basically electrons on the outermost shell, and we discussed about effective nuclear charge, which is most important of all topics in this chapter, which basically you can calculate from Z effective is equal to Z minus sigma. Sigma is not number of valence electrons, it is the shielding constant. You have to calculate using a special formula called a Slater's rule, but we don't have to do it in this chapter. We just need to know the trends of the Slater's rule from left to right. It increases. And atomic radius, we talked about it using the basis of effective nuclear charge, and we talked about ionization energy and electron affinity. Atomic radius, ionization energy are easier to predict compared to electron affinity. So electron affinity is going to be a little bit more challenging, but still manageable. You need to do some practice work on it. And we talked about metallic and non-metallic characters. Basically, we said metals likes to lose electrons, non-metals likes to gain electrons. And we talked about once ions formed by main group elements, and once ions formed by main group elements, how they would like to achieve the isoelectronic configuration. Like if group 1 element is going to lose electron, it forms +1 charge by losing 1 electron, and group 2 element is going to form an ion, it's going to lose 2 electrons. And I didn't really discuss a whole lot on ions of P block elements because we don't want to mess with them much, where we get distracted a lot. But at least one topic we discussed from that is when you have to form ions from D block elements, you still need to remove the electrons from the largest shell, like 4s. If you have 4s and 3d, you have to remove electrons from 4s first. And ionic radius, very interesting topic. Like depending on either an element is losing electrons and gaining electrons, either forming cation or anion, ionic radius is going to greatly influenced. For cations, ionic radius is going to be smaller than atomic radius. For anions, ionic radius is going to be greater than the atomic radius of the same element. And we end our discussion with isoelectronic series, which means depending on whether element has positive charge species or negative charge species, sometimes they have same number of electrons, which you can calculate from the formula of E is equal to P minus charge. Once you calculate the, once you find a species with similar ionic series, you could predict the size of those ions in comparison with the noble gas that they were isoelectronic with. In general, cations are always going to be smaller than the noble gas, even if they were isoelectronic. And anions with a smaller negative charge are going to be smaller in size compared to anions with a larger ionic charge are going to have a larger ionic radius. I'm just signing off on chapter 4, and good luck on preparing for it. We will start on chapter 5 when I see you next time in class. From here, what we are going to talk about is general regions of the periodic table,